Welcome back to another lesson on Python. In this lesson, we will cover process flows and if statements. The purpose of these process flows and if statements are to control our the way that our program runs. So we've started to see some if statements when we did our RPA. So for example, depending on what kind of input we see in the Excel sheet, we may select different options in the drop-down list. So let's take a look at the content for this lesson. So we will be covering operators, process flows, if statements, nested if statements, and I will also be showing a worked example to help you put everything together. So without further ado, let's actually start with the operators lesson, or the operators part of the lesson. So operators are simply examples of operators would be like your divide, multiply, your add, subtract, creating exponential. These are actually in order of precedence. So you remember in primary school, you would always do your divide and multiply before your add or subtract. So the same applies here. So if you want to print something like 5 plus 3 times 4, you will always do the 3 times 4 first before you add the 5. So let's take a look at Jupyter Notebook to see how this works. So as we saw earlier, when we want to print 5 plus 3 times 4, and we have both plus and multiply in the same line, we will do the multiplication first. So 3 times 4 gives us 12. Before we add 5, that gives us 17. So aside from our usual operators, we also have other operators that help to make our life a little simpler. So there will be certain scenarios later, for example in the chapter on loops, where we need to increase the variable by a fixed amount. So that is where this, what we call Inplace Operator, comes in handy. What it does is that it combines a usual operator such as a multiply, plus, or divide with an equal sign. And what we do is that if it's a plus equals, we just simply add the variable on the left to the variable on the right, and then assign it to whatever variable is on the left. Sounds complicated, right? But actually it's quite simple. Let's take a look at this in Jupyter Notebook. So without in-place operators, what you would do is you would declare a variable such as a equals to 5, and if you wanted to increase it by 5, you will assign the value of a plus 5 to a. So because a in the earlier line is 5, so it's actually 5 plus 5 equals to a, which is 10. So let's run this, and here we have verified that a equals to 10. We are simply replacing the a in the middle with or rather equals a plus with this plus equals. So this line and this line are essentially doing the same thing, and they mean the same to the Python compiler. So let's try this out. So it essentially takes the value of 5, a is 5, and we are trying to add 5 to 5 and assign it to the value a. So let's try different values. So let's say it's b, and we want to print b. You will see that we get the same value. So let's try out also adding different values. So if I convert this back to a plus, and we change this to, for example, now b takes the value of 8, and 8 plus equals 5, that gives us 13. So b after this line should take the value of 13, 1, 3. And we see that that is the case. Aside from our in-place operators, we have one last class of operators, and they are primarily used as comparators. So some comparators are if we want to compare whether two values are not equal, whether they are equal, more than, less than, or more than equal to. We will use this in conjunction with Boolean variables, which you learnt about in your last lesson. So let's take a look at some examples on the right. Let's just dive straight into our Jupyter notebook again. So x will be a Boolean variable which takes either true or false depending on whether the statement on the right is true. So we learned earlier, what is this exclamation mark and equals? This is actually the not equal operator. So it's akin to asking the computer, is 5 not equal to 3? If the answer is yes, then x is true. Therefore, when you print x, you will see that it's true. So the moment x 3 is not equal to 3, this becomes false. So it's akin to asking, is 3 not equal to 3? The answer is no, therefore x is false. Next, same thing. We are asking, is 5 smaller than 3? If the answer is no, then x is false. And when you print x, you will see false. So if you change it to smaller, it becomes true. So is 4 equal to 4? If the answer is yes, then this will be true. And you can also replace one of these numbers with a variable. So here y equals to 4 is 4 equals to 4 because y is essentially a 4. And if the answer is yes, then x is true. So that brings us to the end of the lesson on operators. See you in the next lesson where we will be extending the use of these comparators and show you how it can be used in a larger program. Thank you.